Welcome back, everyone, for another deep dive. This time, we're going to be taking a look at Mersenne exponents and how they're connected to those really interesting Mersenne primes. And it all kind of comes back to this OEIS sequence A00000043, which is dedicated to keeping track of all of these special exponents.
It's a really interesting sequence. Mersenne primes are already kind of a big deal in the world of math. They're prime numbers that you get when you take 2 raised to the power of some other prime number, and then you subtract 1 from that.
So like if we had a prime number like 7, 2 to the 7th power, that's 128, and then minus 1 gives us 127. So both 7 and 127 are prime. So that means that 7 is a Mersenne exponent.
Exactly. That's a
Yeah.
perfect example. And what makes Mersenne exponents so interesting is that when you're trying to find them, you're not just checking one prime number. You have this double condition that has to be met. Both the exponent itself and the result of that 2 to the p-1 calculation have to be prime.
Oh, so it's like a 2-for-1 prime deal. It's a
Yeah.
pretty strict requirement. I was actually messing around with some numbers earlier, and I got tripped up by 11. 11 is prime, but 2 to the power of 11 minus 1. Well, that's not a prime number at all.
Yeah, that's a great example of how tricky they can be. And it makes you appreciate how rare Mersenne exponents really are. Even after looking through tons of numbers for centuries, we've only found 48 of them so far. And that's where OEIS A00000043 comes in. It lists every single one of these Mersenne exponents.
So it's like a roadmap for number theorists.
Kind of, yeah. And what's interesting is that this sequence, even though it's finite right now, is thought to be infinite. We haven't been able to prove it for sure. But there are lots of people looking for more Mersenne exponents, and they might be searching forever.
Infinite Mersenne exponents. That's pretty wild. I mean, it really makes you wonder what secrets are hidden in these numbers, especially since even someone like Euler made mistakes with them.
Oh, yeah, the Euler story. It just goes to show you that even the most brilliant minds can make mistakes when working with these complicated ideas. Euler got a lot of Mersenne exponents right, but he messed up and included 41 and 47.
Wow, so even he wasn't perfect when it came to these numbers.
Nope. It just shows how challenging and interesting these special primes and their exponents can be.
Yeah, for sure.
Yeah, Euler's mistakes really highlight how tricky these numbers can be, but the thing is that difficulty is actually part of what makes them so valuable. It's not just about adding more numbers to a list. The search for Mersenne primes and their exponents, it's really connected to some really fundamental questions about prime numbers in general.
Okay, so it's not just like a number hunt. There's a bigger reason for finding them.
Exactly. It's kind of like, when you're trying to understand how a whole species behaves.
Yeah.
But you focus on studying one really rare and fascinating subspecies. Well, prime numbers, they're like the building blocks of all the other numbers. And how they're spread out, along the number line has been a puzzle for mathematicians for centuries.
So Mersenne primes, with that specific formula, 2 to the p-1, they're kind of like a testing ground for those bigger prime number theories.
Exactly. And this is where OEIS A000043 becomes more than just a list. Every new Mersenne exponent that gets added to that sequence, it's like another piece of the puzzle. It might seem abstract, but the more we learn about Mersenne primes, the closer we get to understanding prime numbers as a whole.
I see. So it's not just about these individual numbers. It's about what they can tell us about all numbers.
Right. And it's not just theoretical either. There's a huge challenge in computing these Mersenne primes. I mean, the biggest prime number we know of right now is a Mersenne prime.
And those numbers are huge, right? I think I read about one that had millions of digits.
Yeah, they're massive. Just to even work with numbers that big, let alone figure out if they're prime, you need some serious computing power. The hunt for Mersenne primes has actually led to the creation of some incredible algorithms and even whole projects like GIMPS.
GIMPS? That sounds familiar, but I can't remember what it is.
It stands for the Great Internet Mersenne Prime Search. It's a distributed computing project, which means it uses the power of thousands of volunteers' computers all over the world, all working together to find the next Mersenne prime.
Oh, wow. So it's not just mathematicians working on their own?
No, it's a global effort. It's like citizen science in action, and it really shows how much interest there is in these prime numbers. There's the excitement of finding something new, of course, and potentially being the one to discover a new prime.
It's like a modern-day treasure hunt.
Yeah.
Except instead of gold, we're looking for these giant numbers hidden on the number line.
Exactly. And it's not just bragging rights either. New discoveries often lead to advances in computer science, especially in cryptography. The stuff that deals with secure communication and data encryption.
So this whole thing with Mersenne exponents and primes, it's really bringing together fascinating math, cutting-edge computer science, and just plain human curiosity.
I think that's a great way to put it. Who knew that a formula as simple as 2 to the p minus 1 could lead to so much complexity and intrigue?
And we can't forget about OEIS sequence, A00000003. It's quietly keeping track of every Mersenne exponent we discover. It's like a record of our progress and a map for future exploration.
Yeah, it really makes you wonder what other mathematical treasures are still out there just waiting to be found.
Yeah, it really makes you think, something as basic as prime numbers still has so many mysteries. Even after all these centuries of studying them, there's always something new to discover.
I know, it's really amazing. It really speaks to the never-ending nature of math. It's not like some finished book. It's more like this giant universe that keeps expanding. And all those unproven ideas, like the one about the infinite Mersenne exponents and A00000043, they just make it even more exciting.
It is exciting to know there's still so much to explore, even in a field that seems so established.
Right. The search for Mersenne primes and their exponents is an adventure. It shows how curious humans are and how we just never stop trying to learn new things.
And with each new discovery, we learn more about not just those specific numbers, but also about the rules that govern the whole number system. It reminds us that even in math, which can seem really abstract, there's still a sense of wonder and excitement.
I completely agree. It's a journey that's both intellectually stimulating and super rewarding.
So as we wrap up this deep dive into Mersenne exponents and OEIS A00000043, what's the one thing you would want our listeners to think about?
I'd say the next time you come across a prime number, take a second to really appreciate how fundamental it is. And if you're feeling adventurous, try plugging it into that Mersenne prime formula. You never know, you might just stumble onto the next big mathematical discovery.
And if you do, make sure to let the GIMPS folks know.
Mm.
Until next time, keep exploring the amazing world of numbers.